Okay, hello everyone. So now today is Q&A session number 2 for your week 1 lecture series materials. I do have many examples to show you, but I believe the chat message now is not working. So feel free to actually post questions if that hasn't been asked yet on the chat panel. Okay, we'll start. Again, interrupt me anytime if you wish. You can feel free to speak up. I wouldn't mind. Or you can put in the chat message. I'll try to review the chat panel periodically. Okay, so let me just tell you what I want to talk about today. I want to clarify certain concepts about contracts, which I did talk about yesterday, but I just want to give you more examples so you can definitely reflect on those examples. And OFAC actually asked a very good question about class invariant versus precondition. I definitely got some new example for that, but that will be the second item on the agenda. But we'll get one by one. Okay. All right, so first of all, I would like to start with about why design by contract can be useful for your developments. Okay, so yesterday I talked very briefly about the points that you should really remember. Let me just review very quickly, just mention the points, and then let's see how this can be applied in a concrete example. So what I said was, first of all, the contracts are for guiding your implementation. So guiding is really important because without the contracts, you are basically alone as an implementer. However, if you got contracts, you have some extra layer of assurance to make sure your implementation is okay. We'll see exactly how that happens. Okay, number 2, the contract does not have to be efficient. One of you, I forgot your name, one of you mentioned that if you simply just want to run a linear check on the array, if the array has 1 million elements or even more, then it will be very inefficient. In that case, you wouldn't actually, it would be okay to actually have the contract being inefficient because we could turn it off later. I'll show you what I meant, okay? And then the implementation, it should be efficient whenever you can make a, for example, if you implement a tree, it should be balanced, for example, right? And also, if you want to implement a map, maybe you should really choose a hash table, right? That's about implementation. But implementation efficiency is not really the focus for this course, okay? And then once you're sure everything is working, so now I will be a little bit more precise about what I meant by everything's working. Basically, you're reaching a balance for like how every feature, client and supplier side, they're all working together without any problem. That's what I meant. Okay, so remember these 4 points from yesterday. And then let me just remind you, the recording was up from the website, okay? If you simply just go to our lectures page, you can see September 14th, that was yesterday. If you click on that recording there, it's there. And then you will see that there's a roadmap of all the timestamp just to make it easier for you to navigate. Okay, just make use of it for your learning. Okay, let me go back here. Let's now talk about one concrete example to see how we can make a design by contract be our guidance, okay, to help us. So let's consider this particular example. I will also show you the running on my computer. I'll also make a source code available to you. So that's kind of like a nice case study, okay? So what we want to do, let's say we want to develop an easy console application eventually. We want to have a little database, and then we can insert items into the database, and we can query about whether a particular item exists in the database. And apparently, a very efficient way of inquiring about a database would be to do a binary search. But we know that for binary search, there is a very important precondition, which I'm pretty sure you know what it is, but we'll get there, okay? So let's talk about what this example is about. Let's set the grounds, and then I'll talk about different versions and how the design by contract can help us evolve between the versions. So from the client's view, we're going to develop a console application, which means I'm going to type from my keyboard, okay? Of course, you can easily generalize this into some GUI application or maybe to some mobile or web application, okay? So we're going to keep entering names randomly until it is done. So enter any name you like. And then you're going to keep inquiring if a name exists, and then until we say quit, okay? I'm going to demonstrate to you okay, let me demonstrate right away, okay? So I'm going to see from here. So this is the project which I will make available to you after today. And then I'm just going to, let me see in the chat, someone asking about a quiz. I will get to you, okay, in a moment. Let me not be interrupted here, okay? I just want to see if that's about this particular example. Okay, so now let me show you this. Every time, for those of you who actually got a chance to go over the pre-study PDF, if you haven't, that's okay, I'm showing you now. If you look at your project folder, so there is a folder over here called ifgens. So this would be only useful if you want to invoke the command or the executable from the command line. In our case, because we're building a console application, so this will be handy. Okay. So now what I can do is, so the project name, I just simply say why DBC useful. Okay, just make it very informative. So now I want to show you exactly how the application work, and then we'll see how we can develop towards that ideal version. So now ifgens over here, and then why DBC, that's a project name. And then we haven't really finalized our project. So it's in somewhere called W code. You can think about W code folder is like an intermediate format. It's not finalized yet, okay, W code. And then this is the executable, okay? As I said, for your labs, you don't really have to worry about this. However, later on, when you get to after the reading week, you will have to actually worry about what's the executable inside the ifgens. But for now, it's okay. Okay, I just want to demonstrate to you so you know such thing exists. So now if I simply try to run the executable, so the way I set it up is we're going to have 3 different versions over here. Version number 1 is without any contracts, and we're going to run into trouble. And I'll show you exactly what the trouble is. Version number 2 is when we have contracts, and then when things go wrong, contract violation will occur, which will be expected because they can really tell us something goes wrong, and exactly one side, either supplier or client, will be to blame. And then for version number 3 is actually the final version where everything works like a reach an equilibrium, you know, like in a balanced way. And then version number 3 will be the final version. So let me run the final version directly to give you the idea. It's a very simple application. I'm pretty sure you can do it as well, but you can definitely study the source code if you wish. Okay, if I invoke it, I will simply, let's say I try to enter simply just string, okay, in a way that's not sorted. Let's say E, C, D, A, and B, okay? As soon as I'm done, I'm gonna say done. So this line over here is printing out. So let's say internally the supplier is storing the names entered so far using an array. And then this is exactly the contents of the array. And then you can see that's actually sorted. And then you can think about the next step internally for the supplier is to pass this, whatever this array is, into a binary search routine. Apparently you can see, given a sorted array, the binary search can do its service, right? So now we can simply try, for example, we can try to, and then we can now keep inquiry. You can think about this as a second stage. We have already established the database, so now we can ask. So we can say, does A exist? It does exist, which is correct. B, does it exist? Yes, C, D, and E. You can see everything that we have entered so far, they do exist in the database, right? And then we can say quits. Okay, this is the final version we would like to achieve, okay? But in order to really let you appreciate how the intermediate stage of the development can be guided by contracts, I want to show you from scratch, okay? So hopefully so far it's clear what my intention is, okay? I wouldn't show you too much about the code. Actually over here in the iPhone Studio, I'll make the source code available to you so you can feel free to refer to it. I'll show on my iPad the contract view to show you the most important stuff, okay? Okay, as I said before, for the supplier, they're going to store all the names into an array. And then they're going to pass the array into a binary search. So now what's really important is whether the supplier actually sort this particular array before they pass it to the binary search. That's really the precondition for binary search, right? We even talk about this actually in the week number 1 series, okay? So now let's talk about version number 1. Let's think about, let's say version number 1 is what we develop initially, okay? Let me just go over with you. It's like a contract view showing only the contracts. And then you can assume the binary search is performing correctly. And by the way, for the binary search, you can also see how recursion actually works in iPhone. So that would be a very nice case study for you. Could be useful for your lab 1. All right, let's take a look over here. So we got version number 1. Okay, so you can think about the database would be the clients. And then there's another class over here called utility. I just call it version 1 as well, just to correspond to the version. And this will be the supplier, okay? The client is using some service from the supplier. So for the clients over here, we got adding a name, check to see whether the data exists, and try to initialize the database to be empty, right? Very obvious. And then let's say this, and then in the utilities version number 1 over here, we do have a binary search. So this is going to implement binary search. And now look at this. This is the contract view, right? This is the contract view. However, from the interface of this search, can you see any precondition, like a required clause? Apparently, we cannot. So that means the version number 1 supplier does not require its clients to give a sorted array, right? So they are suggesting if you want me to do the search, I can take any array. Of course, if you're going to do a linear search, it doesn't matter if the array is sorted. But what we assume is this: the supplier, the implementation is going to be a binary search. That's something we assume. Okay. So you can think about it's kind of like a very careless supplier. They actually implement the binary search internally, but they forgot or they overlook to actually require their clients to give them a sorted array. So nothing is constraining A over here. Okay, just understand the situation. Okay, let me go over the key points over here, and then we're going to see how version 1 will behave. Okay, it's going to be interesting. So the database array is not kept sorted. Okay, so now for this particular clients over here, the database, whenever they pass the data over here, it's not sorted. Okay, so you can see somehow this client is also not being very cautious, because when they ask to see where the data exists, they really don't care to see if the array is already sorted, even though they know they're calling a binary search. So both sides are not being very careful. Okay. Okay, the array from the client side, from the database, is not sorted, and also from the supplier side, they do not require the array to be sorted. Okay, so both sides, maybe they are being careless, both of them. Okay, does not require, and also is unsorted order. Okay, so now what's really interesting is I'm gonna demo to you on the command line. What we're gonna see is somehow the client is going to pass an unsorted array to some binary search. Apparently, we know that if you do this into binary search, you're gonna get unexpected result. Okay, let me show it to you. So let me go back to the command line over here. Okay, let me just clear this. Okay. So what I ran previously was version number 3. That's the ideal version, but now we're doing from scratch. So let me try version number 1. That's the very initial edition. Okay, version. If I say that, okay, I'm going to run exactly the same interaction over here. Okay, so now let's say we're going to enter the names not in the sorted order. So I'm going to say E, C, D, A, and B. Okay, and then I'm done with entering all the names. I'll say done over here. So now you can see internally, the supplier has this particular array, which is not sorted, right? That's a version number 1. And then they're going to pass this array as is, unsorted, into this particular binary search that we talk about over here, right? So this one. And apparently you can see there will be no precondition violation, simply because the search routine over here does not require anything about the input array to be sorted. So there will be no precondition violation, okay? All right, and then let's see how what's gonna happen here. So now I'm gonna ask the following, and just ask if A, B, C, D, E, F exists, right? Does A exist or not? It should, but it says that it does not exist. So something is wrong, agree? So the database, well, the whole program, basically, the console application, even though there's no crash, there is no contract violation, but the behavior is simply unexpected. It's simply unacceptable, right? So now let me ask this. Does B exist? It does not exist, right? Also, again, unacceptable. Does C exist? It also does not exist. You can see we have added A, B, and C over here, but they simply were not there. D here. Okay, so now it's being unpredictable, but it says that D exists. Okay, and then E here and F here, right? You can see again, E should exist, but it does not. And F should not exist, and it says it does not. Right? You can see the result is simply just not being correct. So now, what we really should do is, let me switch to the iPad. So what can we conclude so far for this version number 1? Okay, let's think about this. So what we can conclude from over here, you can see all this result over here is unexpected result. And it's simply because we do a binary search on unsorted array. That's really the root of cause. And something goes wrong. And remember what we said as the criterion for a good design. It would be a good design if when something goes wrong, there should be a contract violation. But you can see there's no contract violation here. Everything just run. It's as if there was no problem. But you can see there's a big problem over here. Okay, so now, but no contract violation to signal an error. Okay, that's about version number 1. So version number 1, there's no proper contracts for, especially for the search routine. So that's why even though there's no crash, there's no contract violation, but something goes wrong. So from the client side, they will be very puzzled. The program doesn't crash, but it's not working either, right? You can see what the problem is. So now let's say, okay, any question about version number 1 so far? We okay? All right. So let's see for version number 2. So for version number 2, we're going to improve the matter a little bit. So now we really want to leverage the power or the power of design by contracts. The way to do it is by introducing proper contract. Especially, let's say this. What we realize the problem is when you call the search, the clients of the search should have specified some proper precondition to make sure the array is actually sorted, right? So now this particular predicate over here is really specifying that A should be sorted. So that's something I'll leave to you, right? I talked about it yesterday briefly to say if you got an array in general, how can you make sure it's sorted? You have to make sure for every I and I plus 1, it should be that this is less than or equal to that, right? So that's what we briefly sketched yesterday. I'm going to leave this to you. It's available to you, so you can study that. You can get to me if you got any questions. Okay, so now let's see what version number 2 is about. So the only change we make is we have added this particular precondition on the supplier side, right? Remember we got remember this over here is the clients, and this is the supplier. So we are trying to improve by adding some contract. Of course, in general, for illustration purpose, I'm just choosing a very simple scenario where there's only one contract needed to identify the problem. In general, if you got a big project, you should really do contracts whenever possible. So overall, they're going to identify problems at the earliest timing, okay? And now, let's see what the version number 2 is about. So now, in the database, okay, they will still give you some unsorted array, okay? However, now, the utilities, I mean, this particular search routine, they now require a sorted input array, right? They now require, which means it will be the responsibility of the clients of this particular search to really give you a sorted array. What if they don't? In that case, contract violation is going to occur, which is good because you're going to signal some error to the clients. You shouldn't do this to binary search. Okay, so now what a good design is when something goes wrong, there's one party to blame. And in this case, whoever is calling the search with the unsorted array should be blamed. Okay, let's verify this. Okay, that's about version number 2. Now let's go to version number 2 over here. Okay, let me just quit from version number 1. So for version number 2, I'm going to do exactly the same sequence as before. Okay, so I'm just simply going to say E, C, D, A, B. And then I'll simply say done over here, right? You can see from this, the database, the clients is still really entering, it's really still going to pass unsorted array ECDAB is unsorted, okay? So now, as soon as I say I want to search for A, I'm actually going to call this particular search routine over here, okay, here. As soon as I hit enter there, I'm going to call this particular search routine, which is going to check this precondition right away, right? The first time you call that. And this apparently is going to fail because ECDAB is definitely not sorted as the input, right? You can see that very easily, okay? So what I will do is I'm simply just going to hit enter. And then this is the stack trace that you're familiar with from lab number 0, right? Let me just point to you where you should look at. It's exactly this part here. You can see it's a precondition violation from the utilities version number 2 in this particular search routine. And that is telling you, you're trying somehow in your system, some supplier, in this case database, is trying to, some clients, which is database, is trying to make use of the search routine from the client side, in this case, the utilities, illegally, right? That's exactly the root of cause over here, okay? So now, so what we know is this is actually definitely a better design because in that case, you can see over here, okay, let me just tell you for version number 2, so this is what you should know, okay? Again, so unsorted array is still passed, to binary search. This is still the case, right? The supplier hasn't fixed their problem, but now they actually got warned. They actually got blamed for this. So that will force them to actually do some change, okay? Okay, so now a precondition violation is has happened. So this will actually forcing the supplier to make a change. Okay, that's about version number 2. So you can think about the biggest improvement from version 2 from version 1 is we have added 1 contracts to really make sure if something that really goes wrong, so we wouldn't get into the problem for version number 1. For version number 1, nothing happens, right? And then the program doesn't work. So nope, we don't know who to blame. On the other hand, for second version there, we know that something is not working because contract violation occurred. So that's really a very powerful function for the contract, right? Okay. Any question about version number 2? Are we okay for version number 2? Okay, hopefully so far you followed the story. So now let's move on to the final version, okay? So the final version goes like this. Because now when we actually got this particular violation over here, so now we know that if the precondition is actually violated, it will be the clients that should be blamed, right? So the client in this case would be the database. And the problem is the database class, when they actually call the search for the supplier, they did not sort the array to begin with before they pass it. So that's a problem. So this will force the supplier to actually change whatever they have to do for the array. Okay, so let's now go to version number 3. Okay, version number 3, let me just go over with you what's happening over here, and then I will demo final time. Okay, for version number 3, database and also utility, the same setup. Okay, so now what's going to change is the supplier over here. It's not really shown in the contract view, but you will see that when you see the source code. Okay, so you can think about this part over here. They will actually sort the array first before they pass to binary search. Let's just go over some points over here. Okay, so the database is going to keep the array sorted somehow. It's a little bit similar to like a insertion sort. Okay, so which you learned from 2030. So the way to do it is by whenever you add something to like insertion sort, yeah, whenever you add something to the array, you want to keep the array sorted, right? So you have to find the correct spot to insert the sorted item. And then the utilities still require this particular precondition, which is good. Okay, so in order to pass this particular precondition, the supplier must keep the array sorted. That's basically some improvement that the supplier was forced to make. Okay, so now the final outcome is a sorted array is always passed for search. So that's good. So that's really, without the contract, we wouldn't get this kind of guidance, right? That's really the key I want to demonstrate. Okay, let's do a final demonstration over here, and then I'll show you what I meant by contract can be turned off once we believe everything's working. Okay, so that's about version number 3, which I just explained. Let's run it just once more. We did it in the very beginning, but let's just run it one more time. E, C, D, A, B. Okay, so that's unsorted in the unsorted order. But now if I say done, so now you can see the supplier actually, they will keep this array sorted somehow, right? You can look at the source code to see more details. And then if I say, for example, A exists, right? It's the correct answer. And then I say B, I say C, D, and E. So they all exist. So now the program is not working, right? But you should really see how we can evolve, how we actually manage to evolve to this particular version that everything's working, okay? So now we believe the console application is now working, right? And then as one of you guys actually pointed out, the checking of this particular precondition over here is very inefficient because it's simply going to go across the array from lower until upper, right? So if the lower is 1 and the upper maybe 1 million, then that will require maybe 1 million iterations to go through to check this counter. Very inefficient, right? I agree. However, when we are still developing our projects, we do really need this kind of, we want to trade correctness for, we want to trade inefficiency for correctness. So even though it's inefficient, but I think that can guide us towards correct developments. So now when we believe everything is working because the supplier is now passing a sorted array to the search always. So as far as the application is concerned, now we are okay. It's ready to be shipped to the customer. So one more thing I want to show you. So you believe that's the case, what you can do is in iPhone Studio, you can simply say, under the compile, there is one option here called finalize. Okay, when you say finalize over here, you can simply say over here, let me see. Okay, now here, you can simply say yes. And then this is actually interesting here, right? This is exactly the option I want to talk to you about. They said by default, assertions are enabled, which means all the contracts are being checked, including that linear time precondition that we talked about. So now if you say, I want to discard the assertions, and once I say that, it's going to finalize and recompile from scratch. And then whatever code that's being generated will be without the contract checking. So you can see but this should be the very final step you do for your developments. Okay, so now if I go back to over here, quit. One more thing I want to show you before I take any question from you. Okay, so now if you go to ifgens, let me just go into ifgens and this particular project over here. So what we should now see is something in the F code. That's a finalized executable we can see. So this is the version where all the contract checking is turned off. But we can only do that when we believe we have used the contracts to guide our developments until the final stage, as I show. And of course, this is only a simple example with only one change. But realistically, you might need different versions over there. But you got to use contract to guide it. All right. Any questions about this particular case study over here? I think this is actually really meant to really show you, give you a big picture why we're doing this type of contract in this course, because it's really a good like an extra layer to really make sure your developments can be guided by obligation and benefits between clients and supplier. Okay. Any questions about this particular example? It's somehow definitely related to your week number one, but I do want to think about this example here, right? No questions? Okay. Okay, let me take a look at the chat over here. So the question was, for the quiz, do you just go over the lecture videos and lecture slides? Yes. In principle, yes, unless I tell you that this coming quiz is also going to cover anything extra, I'll definitely tell you explicitly. Otherwise, it's always going to be lecture videos and lecture slides. How many questions should you expect? I believe if you check the announcement I made last Friday when I first opened the quiz number one, I did say about how many questions and how much time you're given. Please check it. Just check it. Yeah, I think that's something you would have known already, right? Very good. Okay, guys, I think this case study here is not exactly on your slides, but I think you'll be hopefully can help you understand a little bit more. You want to be convinced why we are doing this in this course, right? All right, so that's about this example here. I will make it available to you, and you can also take a look at how binary search is done in using this design language. Okay. For lab number 0, I didn't specify the celebrate to have any precondition, okay? Okay, over here. Okay, so it's really about lab number 0, about the celebrate routine, okay? Let me talk about this quickly, and then I'll move on to the next question, okay? Let's say the birthday book you have is this. You have the name, and you have the birthday, right? Let's say let's say maybe Alan. Let's say March 14th, and also let's say Mark. And then we'll have, let's say, 4th, let's say April 3rd. And also we have Tom over here. Let's say also March 14th. Let's say this is our birthday book, okay, conceptually, right? So now you're really asking was, okay, when I say bb dot celebrates, okay, I can pass any name over here, any dates of today. So Nina, you were asking, why did I not specify any precondition? So what kind of precondition do you think I should specify? You want to suggest anything first before I respond to your questions? What kind of precondition do you think you need? So Nina, do you want to respond? Unless you want me to just continue. If the date exists, what do you mean if the date exists? Well, you can pass any, the name should be in the database, but remember for celebrate, what does it take? Celebrate only take, for example, today as a date, right? It's a birthday. It does not take any name. So you cannot check if the name exists or not. So that's not possible, right? So now in terms of the precondition in this case, I think I want to talk about something you learned in 1090, right? So in 1090, you learn about something, the difference between total function versus partial function. Can anybody explain to me the difference between total function versus partial function? Anyone? Don't be shy. It's okay to be wrong. Total function versus partial function. If you want to speak up, just speak up. That's fine, if you wish. Anyone? Partial function is like a helper function, not really. So when you say a helper function, it's already almost like a programming idea. So I'm just talking about theoretically, you know. Let me give you some guidance over here. I'll help you a little bit. In case you forgot about the definition, that's okay, but you should pick it up again, right? So let me give you choices. Number 1 and number 2 over here, right? So let's say if I have, let's say divide, and then it will simply take x and also y. The type would be obvious, simply just integer, let's say, okay, or real, just say integer. I got another function over here, let's say absolute value. And then it will simply take one single integer. Okay, for 1 and 2, one of them is a partial function. The other one is a total function. So now which one is partial? So now like a matching answer, right? Partial function and also total function. So which one is partial and which one is total? 1 and 2. For those of you who might still have no clue, I may want to give you one more hint. So the way to define partial function and total function is about domain value. Domain, right? You know what a domain is, right, for a function. Okay, so Jalel, you say 2. Well, 2 is what? So you're saying 2 is a partial function? Not quite actually, but you know, it's a good try. Okay, so okay, that's okay. You know, let me tell you. Okay, hopefully you will pick it up for next time. A partial function is 1, and total function is 2. Okay, so now you can think about a partial function over here is basically like the precondition is simply just true, like a tautology, right? On the other hand, when you talk about a total function over there, so the precondition there, oh, I beg your pardon, I said the opposite. Let me say it again. Sorry about that. Let me say it again. So for total function over here, total, right? Total function. So that means the precondition is simply just true. It's as if you said required true. On the other hand, when you say partial function over here, it is precondition, it's just something that might evaluate to true sometimes, but also sometimes might evaluate to false. It's a contingency, right? So this will be just some predicate over here, okay? Let's see why in this case, right? So now for divide, is there any precondition? Well, as we learned from W1, there is. So one is one over here is a partial function for sure. One is a partial function because there is a precondition to say here the divisor over here should be not equal to 0, right? That's a precondition. On the other hand, whenever you try to calculate the absolute value, do you have any constraint on its precondition? You don't, right? Because I can calculate the value for absolute value for integers. For example, I can calculate for negative value. I can calculate for 0. I can only calculate for positive value. So I can cover the whole domain of integers for the parameter type, right? So now, because no constraint on the precondition, on the input value, so there's no precondition. Okay, the notion about partial function versus total function is really important. Okay, so at least you can see the explanation. So now when we talk about this particular celebrate over here, right? Because over here, the today, so it's simply just going to be a birthday object. And we know that in order for the birthday object to be valid, the month should be valid, the day should be valid, and also the combination of month and day should be valid, right? That's something that's guaranteed. So when we're given this particular birthday object, right? So now, it's more like a design choice over here. If you want to put a precondition there, you can simply say, maybe I want to say the birthday over here should be existing in the database, in the birthday book. That's one way to go. However, the way I explained it was like this. I say that like this. If I say BB celebrates over here, if I say, if I pass, let's say March 14th, right? I'll just say March 14th, I'll put it like that so you know what I meant. So if I say March 14th, it is going to return an array of size 2, right? It's going to be Alan and also Tom in the array. But now, for those of you who already watched the video for that part over there, what if I say this? If I say celebrates, and then I'll simply say July 2nd. Now, according to what I said in the video, what should be the return value over here? Does it return, does it cause a violation, or does it return some value of the array? So that's critical. So Nina, you asked me the question, why don't you try to answer? So according to the video, if I actually pass some dates over here, that simply doesn't exist in the database, right? In the birthday book. So what should be the celebrates return? Anyone want to answer? An empty array? Yeah, you're absolutely right. Exactly. For Hoy, you actually put empty string, but I think you meant to say empty array, but you really want to be precise. Okay, very good. It's simply just going to return an empty array. That's exactly right. So you can see it's more like a design choice I made already for you. So when you call some dates with no corresponding names in the current birthday book, rather than causing a precondition violation, I simply just return an empty array. So that means my design choice is, for this particular celebrate, I want to make it a total function mathematically, which means I restrict nothing. I don't restrict any, I don't put any constraint upon the input values. So any date you can pass, either existing or not. It's just that when the name doesn't exist, I'll simply return an empty array. Okay? It's a design choice. Of course, later on when you do your project or your lab number 3, you definitely have the total freedom as to what kind of contract you want to add. Again, it's a design choice, but you're only starting to learn about this concept over here. That's why I made the design choice for you. So for the celebrate, there's no precondition because I want to make the celebrates a total function. And to make it, I need to be able to handle all the possible inputs. In this case, the birthday either exists or doesn't exist, right? So Nina, does it help? I hope. All right. Good, very good. Okay, so that's about your lab number 0. So guys, I hope all of you are really finishing your lab number 0, even though the deadline is next week, even though, right? But I think it will be to your best interest of finishing lab 0 as soon as possible, as I kept emphasizing. Because for your lab number 1, which has been released since yesterday, it will help lab 1 a lot if you can finish lab 0 earlier, because I cover all the basics about the syntax. Okay, but I know you guys are trying hard. Just keep trying. All right, so now I want to return to Ophic's question from yesterday, right? Which I promised that I will come back to this because I need to set it up. Okay, so hopefully Ophic, you're here. I hope. All right, so now let's see. Good. Okay, let me just rephrase your question a little bit, just so that it's more like a mini lecture. Okay, I think it's a very important concept over here. Again, it's more like a design decision, as I would put it. Okay, so it's like a design decision here we want to make. Basically, the question really is, if we have a choice, would we rather have a class invariant violation, or would we rather have a precondition violation? If a violation must occur, which one should be more desirable? So from what I responded yesterday, it sounded like maybe it's equivalent. So either you can have this or you can have that. It doesn't matter which one, as long as you commit to one. But I want to illustrate to you, actually, having a precondition violation will be much more desirable. To make it very brief, first of all, before I go to this example here, I got another example for you, which is a little bit more related to your 2011, your data structure course, so you can draw more connection there. So a very quick recap, quickly. The reason that the class invariant violation will be the last kind of violation you want to make. Let me write it here. This will be the last violation you would like to have. You would want to have, because if you have a class invariant violation, let's recap. Let's recall what class invariant really is, right? So whenever you, let's say for the account class, right? The class invariant is simply saying the balance should be always positive, right? That's according to the requirements that we talked about in the W1 lecture. So whenever you so that means class invariant tells you under what circumstance should a valid object be considered, especially for the account. So in order for the account to be valid, balance must be strictly larger than 0. So the worst scenario you can get into is when you actually have account objects whose balance is strictly is actually less than or equal to 0, the opposite of the class invariant. That's the last scenario you want to get into, okay? Because that means you have invalid objects. You have an invalid objects. Okay, it's really important philosophically, you should understand, right? Invalid objects. So class invariant, if you can avoid, you should really avoid at all cost. So now what I want to illustrate to you using the account example is to first show you the two alternative and then convince you, and then we'll go to another more complex example, okay? Let's just go over the two versions over here. So version number 1, let's say there is no precondition there, which means we're going to result in a class invariant violation, okay? And version number 2, we're going to see how the precondition can be designed in such a way that it's going to prevent the corresponding class invariant to occur, okay? And let's go over this quickly. Let's say for the first version over here, account, we have balance and then we have the corresponding invariance. Okay, we have set it up properly. So now if you look at the make over here, let's say we talk about just constructor and only constructor. Later on, you can also generalize this into routine, query, or command, the same idea. Okay, let's say for the constructor here, we don't have any precondition. Okay, let me emphasize that. There is no precondition. The only thing we have is the postcondition, which is quite obvious, right? That's not a big issue, okay? That's version number 1. For version number 2, everything is really the same, except, I'm gonna highlight to you, except that we have a require over here, and the require actually got exactly the same as the class invariance. Okay, you might think, does that mean we simply just copy and paste the class invariant over here as a precondition? I would say in some cases, yes, in some cases. However, towards the end of the course, maybe about the last 1 or 2 weeks, we're going to talk about program correctness. So that one is more about a theoretical foundation for you to design proper contracts. And then one of the topics called the weakest precondition, which means given a particular class invariance, how can you calculate systematically what the corresponding precondition should be? But I just want to give you some idea abstractly, but we will see exactly how to do it using what you learned in 1090 at the end of the course. That will be also some practical technique you will pick up using math, okay? But for now, let's say this. Because we know that what the last scenario we want to get into is by violating this particular class invariant, because that means we got to invalid account objects. In that case, we'll simply say, in order for me to initialize from this particular init balance, I want to make sure it is such that the initial balance is strictly larger than 0. So it wouldn't be that if I set the init to be, for example, if I simply say init is -4, for example, in that case, so -4 will be the balance. In that case, I will simply violate the invariance, which is not good. I don't want to get into it. So instead, if I have -4 over here, since I got a precondition over here, so I'm going to get a precondition violation instead. Okay, so now let me just recap this example here. Let's run these two versions together and see what the difference is. Okay, let's try over here. Let's say this is a client code over here. So we got ACC, we got account over here. So let's say we simply try to call this particular command, which is at the same time a constructor, because we declared that over here, right? Let's say we pass -100. Let's see what the behavior, how the behavior will be different from the version number 1, version number 2. Okay, for version number 1, which is the blue over here. So now, any idea? So what's going to happen for version number 1? So Jalil, you said these violations are compile time errors, right? No, actually they are not. Whenever we talk about violations, even though I wouldn't recommend this term, you may approximately think about violation are like exceptions. Exceptions only occur at the runtime. Okay, so violations we're talking about is actually runtime phenomena. They are not compile time. Okay, it's really important to clarify. Okay, guys, let's say this. So here's my question. If I try to call this particular make over here from version number 1, what kind of violation am I going to get? Anyone? Am I, okay, I can make a choice for you. Am I going to get a class invariant violation, or am I going to get a precondition violation? Yeah, Ovek, you're right. It's going to be a class invariant violation because there's simply no precondition, right? So we're going to execute the implementation here as is, and then the balance would simply just be set to -100, which is okay. And then when we check the class invariance, it's going to be violated. Okay, so version number 1, when we run it, it's going to be a class invariant violation. Okay, let's now do version number 2, which is green. For version number 2, well, obviously, when you pass, for example, -100 over here, right, for version number 2, and you're going to check this first for the precondition. Well, -100 larger than 0 is going to be violated right away. So now it's going to be a precondition violation. So now you can see the difference between the design between version number 1 and version number 2. The consequence is different. And now, which one should you choose? And now the guiding principle really is you want to avoid class invariant violation whenever possible. That's really the worst scenario you can get into because you have already created some invalid objects. Why don't you take some precautionary measure to really prevent that invalid object to be created from being created in the first place, right? That's the argument. Okay, so now the winner should be this version over here, right? This version should be chosen, okay? Okay, it's a design decision you have to make. So Ovek, specifically, are you okay with this explanation here? And anybody else? Are you guys okay with this explanation here? Good, okay, very good. So guys, let me give you another example that's maybe more interesting to you because, you know, just checking balance larger than 0 is not very interesting, okay? Let me give you another example here, okay? It's a related topic to your lab number 1, also about binary search tree, but it's not really about like a tree node implementation. So, but you know, just for your knowledge, okay? Let's talk about this particular example. Let me just brush up your memory quickly, right? In 2011, when you talk about binary search tree, right? When you talk about binary tree, so there are at least 2 ways for you to implement a binary tree. Either you can use the link node notation. You can say, I have a node, it has a left child, it has a right child, right? And also maybe they have parents, like a different pointers. That's one way to do it, right? Another way to do it is you can have an array representation of your binary tree, right? For example, let's consider this particular binary tree, okay? Let me just get back to the indices starting with 0 that you used to be familiar with. Just do that, okay? So now the way to really do it, you have to follow some systematic indexing rule. So the root will be index 0, right? So that means we put 46 over here. And then, so now given the index of the root, we have to say times 2. to really get, times 2 plus 1. So let's say this, if this is I for the root, and then the left child is going to be 2I plus 1, and the right child is going to be 2I plus 2. So that's kind of the convention, right? So I'm pretty sure you guys kind of seen this before in 2011. So I'm just telling you the result. So now, so what we can get is we're going to get 1 and 2, and then 3. There's no left child here, so this will be 4, and then 5, and there's no 6 over here, right? Like that. Okay, so what we end up having is we're going to say 23, and then 91, and then for 3 here, let's say just put -1, assuming that -1 means there's no child over there. And then we got 51, we got 68, and also we also got -1. There's no child over here, right? Okay, there's a very quick brush up from what you know from 2011. So now we want to put this example here in the context of 3311 because we know about contracts. Let's see how the contract can help us making explicit what the precondition should be. Okay, so now let's talk about this. Apparently, by the way, you know that even though this is a binary tree, but it's not really a binary search tree, right? You know that, right? Because if you do the in-order traversal, you're going to get 23, 51. So far, so good. But when you go to 46, it's not sorted anymore. So this is a binary tree, but it's not a binary search tree. Meaning that if you simply pass this particular array to initialize a binary search tree, it should be disallowed in the first place. So that would be the kind of precondition you want to have, right? Hopefully follow through this flow over here. Okay, let's now consider again the two examples, right? Again, let's see how we can do it, okay? So now let's see this over here. So let's say for version number 1, so we have binary search tree, and then we have a representation pretty much like this, right? Just one example. And then it's an array of integer. We're assuming that we just store integer keys only in the node, just make it simpler. And then for version number 1, there's no precondition, which means whatever array initialization you pass, it will be set to representation right away, right? And then what about the invariance for the binary search tree? So the invariant for the binary search tree simply means your representation of the array must be always satisfying the search property, which means, for example, over here, you can see, I'll just give you some example. This is the root. It must be larger than its left child. The left child, it must be smaller than its right child, right? And over there, for example, you would see that over here, use a different color. If you see for 91 over here, this should be larger than its left child, and then it should be smaller than its right child. And this is not the case. Agree? I'm just not being very. Well, you kind of see the idea. I'm just give you some idea about how you can do this particular is BST. Given an array that is supposed to represent a binary tree, how can you make sure that's also is going to satisfy the binary search, the search property? That's my point. Okay. So now let's go. How you implement this particular auxiliary query? You can do that as an exercise if you wish, and then feel free to consult with me if you get stuck about doing this. Right? It's not just extra exercise if you wish to do. Okay, let's say we do have this particular helper function over here, so we can check. So now we go back to our two versions again, right? For version number 1, you don't have any precondition over here. But for version number 2, you actually put the precondition over here to say whatever array you want to use to initialize a binary search tree, it must satisfy the search property. Otherwise, we know that we're going to create an illegal binary search tree like this. So it should be prevented from happening in the first place. Okay, so now if you now try this in the client code, we say create bst.make. It's going to take some initialization array. Let's say we simply pass this guy over here, just this array. We know that it should not be a legal binary search tree. So again, we are facing the two versions over here. If we say version number 1, this version here, there is no precondition checking to see that init is actually illegal. No. So we're going to end up having the class invariant violation, right? So it's going to be the class invariant violation. On the other hand, for version number 2 over here, right? For version number 2, it's going to check this particular, if the array is actually a binary search tree representation at the same time. So now what we will get is version number 2 is going to be a precondition violation. Okay, so basically what you should really pick up from these two examples is the following. Let me recap the points. So it's again a design decision for you to make whether you want to have a precondition violation for illegal inputs or you want to have a class invariant violation as a result of illegal input. It's more like a design decision. However, I would say having a precondition violation would be much more desirable. So that means you're taking some precautionary measure before the invalid objects being created. So that's a very important point I want to explain to you. Okay, so now let me take a look at some question here. Okay, just one. From Gillian. Isn't the case that both invariant and precondition would be the same? Yes. Yeah, actually right, you said never mind. But let me emphasize again. You're definitely right. In the simple case like this, it will be just the same because the input is simply just the same type as the attribute over here, just the same. However, you will see, if we encounter this later in the course, I'll give you some concrete example. But I would say in the simple case, it is possible you may just have to copy and paste the class invariant so that you can really let the precondition does the precautionary measure so that you wouldn't get to the violation of this. So you can, but don't get the sequence wrong. The reason that you could come up with this particular precondition here is because you have this class invariant in the first place. If you didn't have this, let's say, how could you come up with this? So both are important. Okay. And then later on, as I mentioned, at the end of the course, we're going to talk about how you can, given a particular invariance, how you can systematically figure out what the appropriate precondition should be. That's something we'll get into later. So we'll see later. Okay, so since I know question here, okay. So now let me go on. I'll keep monitoring the chat panel. Okay, so if you got any question, please just speak up. Okay, so now there's another question on the Google Doc, which might be nice to clarify as well. Okay, so in your tutorial video, I think that when I talk about the across, especially using across as the universal or existential quantification, I use the notation like this. I said, for example, for all x, so x is just dummy variable. It can be x and y. You know, I'm just using one. Okay, and then so I have some vertical bar. I have some predicate here. I have the bullet points, and then I have another predicate. Okay, so this may not be exactly the same symbol you use in 1090, but I think conceptually they are the same. Okay, let me explain that again. Okay, because I'm going to use this notation throughout the course, so you better understand what my convention is. So when I say vertical bar here, that means such that for every x, such that it satisfy the range predicate. I'll give you one example in just a moment. And then the bullet point means it is the case. Let's see one example right away, right? If I have this over here, I say for every x, such that x is in between 1 and 10. It is the case that x squared is less than or equal to 100. That's how you read it, right? So you can see the y in the middle over here is like the range. Let me just highlight it quickly for you. So now you can see whatever that's in the middle over here. So this is the range. And whatever that's actually after the bullet point is some constraint to say for every x that satisfies the range constraint, it should be the case that it satisfies the property as well. Okay. Okay, so far so good, I hope. And then from your 1090, you also learned that, so this is general form over here. So this is the general form I'm talking about, right? You just give a range, also you give a predicate here. And maybe another form you might be also familiar with is you simply say for every x, and then you simply say range implies predicates. That might be something you're familiar with. Okay, that's okay. So these two are just equivalents. So I can definitely use implication if I wish, but I can choose not to, just using vertical bar and also bullet points. So these two are the same. First of all, let me clarify in the case of the universal quantification. Okay, let me do also existential quickly, okay? If I do existential quantification, the same idea, okay? So now I say there exists x, okay, such that. So this will still be such that. However, in the case of existential quantification, the bullet points over here is no longer it is the case, right? It would be easier for you to think about and. Okay, you know what? Let me put it this way. let's make it a little bit easier. You can say it is the case. There exists an X such that the range predicate is satisfied. It is the case. Some property is satisfied. Okay, let's see one example right away, and then I'll get to the conversion which I talk about in tutorial 0. Okay, so now if you look at this particular one over here, I'm claiming that the right-hand side over here is equivalent to the left-hand side, right? Because I'm doing double negation. And the double negation I did was this one negation here and change from for all to exist. And then I only have to negate the predicate part. Used to be less than or equal to, but now it's larger than. You can see that's a second negation, right? So now this is how I read it. There exists an X such that 1 less than or equal to X less than 10, and it is the case, X larger than 100. Okay, that's how you read it, first of all. So Ovek, you said, can we just say X is an element of the set? Yes, you may. So you can say, for example, just put your notation over here. Yeah, you might say for every X, such that X is a member of maybe some set over here, right? And then you can say bullet points, and then P of X. Or you can also use the implication. You can say for every X, it is the case if X is in S, that implies PX. You can also do that, okay? So now let me talk about some confusion from you guys, okay? So before I do that over here, I want to talk about this guy here, right? So this, whenever you talk about an existential quantification, let's say you don't want to use the dot. Let's say you don't want to use the vertical bar. Let's say you don't want to. What you can do is you can simply say, let me just write this down more explicitly, okay? Either you can say, okay, let's say this. Make it very obvious. For every X such that the range, it is the case, PX. This is equivalent to, let's say we want to get rid of the vertical bar. For every X, okay, and then you can say Rx implies PX. Okay, so this is number 1. So what about number 2? For existential quantification, you can say for every X, not for every, they exist. When I say there exists X such that Rx, it is the case, PX, okay? If I want to get rid of the vertical bar here, I can say there exists X, it is the case, Rx. So now rather than using implication, you know from 1090, it would be and, right? Conjunction. Okay, let me just highlight it quickly. So this is just to make sure you understand what the notation really means. And let me go a little bit further, okay? From your 1090, what you learned was, if I have for every X, okay, and then just let's say we don't have vertical bar, and then you simply get, let's say just some predicate over here. And the predicate might contain implication, might contain conjunction, etc. It is simply equivalent to, not the case, there exists X, and then not P of X, right? So you have the double negation over here. This is something you're used to from 1090, okay? So the real question from the Google Doc was like this, okay? I'm just trying to build up, scaffold so that you can understand what I'm trying to say here. So this is what you know very well. It's a double negation rule from 1090, okay? So what I said in the tutorial is, let's say I want to introduce this particular vertical bar so I can specify range and property separately, right? So this is the range, this is the property, right? So now, when I do the double negation, I say the first negation is here, and the second negation is only to the property part. It was not applied to the range part. So some of you was a little bit confused why this is the case. So I'm going to explain to you, okay? So it's very easy to do a very quick proof. Okay, let me do it quickly because I think since you guys asked, I need to answer you properly, okay? Let's do a very quick proof. What I want to prove is this. Let me start with this. For every X such that the range of X is satisfied, it is the case, P of X, right? First of all, we know that it is equivalent to, if I want to get rid of the vertical bar, it will just be for every x, it is the case Rx implies Px. Okay, so far so good. It's only a simple conversion. And then let's now apply this particular rule over here, which you know from 1090. Let me just highlight it quickly. So this is the conversion rule that you know very well from 1090. Okay, this is the one I'm going to use. Okay, I'll just put a box over here so you know which one I'm talking about. So for that one there, I'm just going to say this. So that one there is going to be not the case and change from for all to exist. And then it's going to be double negation. So the second negation would be not the case. Rx implies Px. You know what? Let me move this a little bit. Okay. Yeah. Okay. All right. So now that would be P of X. Okay. So that's about double negation. So now what we have to worry about is this part over here. Okay. Let me do a little bit of sketch along the on the side for you. How do we evaluate this guy here, right? So I'm talking about this guy here, right? This guy here. Not the case. Rx implies Px. And we know from, again, 1090, so what's the definition for? Implication? Not, if you say P implies Q, that should be equivalent to not P or Q, okay? So that'll be not the case, not Rx or Px, okay? So this is the definition of implication. And then this will be equivalent to, and now we can use De Morgan, right? De Morgan. So now so De Morgan double negation. So De Morgan would be, I can apply the not over here to this particular part, first of all, right? So there'll be negation here. So that would just be Rx. And then De Morgan is going to convert from or into and also apply the negation to here, right? I forgot a parenthesis here, sorry, okay? That'll be not Px. Okay, hopefully you agree. So now it's going to be, let me go back here. So you'll be equivalent to, not the case, there exists X. And then this part over here, let me use green. That's something we just calculated. So it would just be Rx and Px, not Px, sorry. Of course, you can see the negation over here. I forgot to include it. So that would be not Px over here. So now we're almost done, okay? So now you can see, according to the form that we talk about over here, you can see over here, if I have this particular form, like Rx and Px, I can turn it back to this particular form, right? So now I'm just going backwards. So now I know that this Rx is good without any negation. So that's the critical part. For those of you who might be confused about what's in the tutorial, this is the key. Because as we have done the math, there's no negation applied to the range. That's the key, right? So finally, it's going to be equivalent to, so this part here would just be not, there exists X such that Rx without any negation. And then it is the case, but this one has negation, Px. Okay, it's mathematical, I know, but since you guys asked me the question to clarify, so I think being precise and thorough would be the best way to clarify your concern. Okay, so if you still have questions about the notation here, please let me know. I think we also talk about many good facts that you learn from 1090. So this course is really about design, and design is not just about programming. You have to be logical about the arguments. So we're gonna see this gradually in the course. Okay. Okay. Orphic asks another question here. Okay, that's a good question. Let me just write it down. Okay, I just saw that on the chat. So let me, Orphic, if you don't mind, let me copy whatever you said on the chat. Oh, it's public anyway. He was asking, can we say the following? Okay, let me write it down here. He said, for every X, okay, and then in 1 less than or equal to x less than or equal to 10. Oh, I see what you mean here. So I think you're just saying to be more formal. I should really see that one. And then I guess maybe you can say another, just say whatever vertical bar or bullet point, right? And then you can put some predicate over here. So this notation over here is fine over here. Maybe that's what you're used to in 1090. I would say at least the reason I'm talking about the notation I'm using here is at least you can understand what I'm saying, okay? However, later on, once we get to the very formal part of the course towards the end, so if you are required to write any proof in the exam, I would say as long as you use one of the notation that's correct, that'll be okay. Either you can use your old notation from 1090 or you can use my notation that you're used to. I don't mind. Okay, maybe often that's what you're asking, right? So my answer to you is this is okay. Very good. Yeah, so you know the math language is for communication. So as long as your language makes sense, I'll be okay for that. Okay, but as long as you can understand my language as well, so that'll be fine. All right, so that's about the math part. It took quite a long time, but that's okay. We still got about 15 minutes. I think I got. Let me finish the final slides, and then we can see if you got any question. We can do some exercise as well. Okay. Okay. Let me see what I want to talk about here. So this is just the final question I saw on the Google Doc. Okay. He was the question of you guys was this: how does the assumption of instructions being followed being the benefits for the supplier? Okay. So now that's the question, right? So now so guys, you can read the question there. So how would you answer this, right? So think about how you answer that. I'll give you my take. Basically, the question is like this. In general, let's talk about in a more programming context over here. And then you can also read the blue one is my response. You can read it too. But let me just give you the programming context here. If you're trying to program some routine in general, okay, the routine can either be a command or can be a query. Let's say it's a command. And then we have a require over here. And then there could be some predicate P, some predicate, right? And then there will be some implementation which the supplier should do. And at the end, we also should check that the postcondition, let's say R over here, should be satisfied. So the two contracts we have is the specification is the P over here and the R over here. And then whatever that's in green is the supplier's secrets. You know, that's their implementation. So the question really is, in order for the supplier to execute this block of code, they can assume that P is actually true. That's what we said in week number 1. So the question was, why the assumption that P is actually true would be a benefit for the supplier? Well, let me just give you an example, right? Actually, if you recall the case study that we did in the beginning of today's session, right? Let's say this. If I talk about binary search, okay, that's exactly the example I'm mentioning here. And then I simply got A and also X. Let's say A is the array to be sought, and also X is the item we want the target item. Okay. So now let's say there's a precondition here. Okay, over here we'll simply just say informally A is sorted. And then when we say do over here, so over here this will be the implementation of binary search. And then we also got some post condition over there. This will be maybe just say A X is in the result or whatever, right? You can look at the case study for detail, but let's concentrate on these two things. This is the implementation, okay? And this is the precondition. So now why the fact that, so when the green one is actually doing the implementation, you can definitely assume that the pink one is actually satisfied. Why would that be a benefit for the supplier? The reason is, think about the opposite. If we don't have this precondition over here, would that be fair to the supplier? So we're basically telling the supplier, if we don't have this precondition here, to say A can be any structure, A can be any shape, for example, unsorted. In that case, we still require the supplier to perform the binary search on the unsorted array and still give us the correct result. We know that theoretically speaking, it is not possible. When you do a binary search, you must make sure you actually got a sorted array. Otherwise, when you give up the left child, for example, the left subtree, it might be the one you give up contains the element you're looking for, right? So that's why it's not fair. Okay, so let me, hopefully that already answered the question. I want to just emphasize the point. The supplier's benefits is that they will not have to work on an unsorted array. Okay, let me just spell it a little bit better here for you. Okay. An unsorted array, so which means it's always sorted. So that's definitely the benefits for the supplier. Okay, it's a very quick clarification. Okay, so now we got about 10 minutes over here. So guys, do you have any questions for me? I'll just pause a little bit. We got 10 minutes. Let me see this. We got one question from Jia Hao. Given violation of precondition will not execute the feature call, it is right. So when the precondition is violated, you wouldn't execute the body of implementation. What is actually happening inside the cache value during the runtime encountering error violation? Okay, so I think what Jia Hao is really asking was how the pre-state values are being cached. So that's really the subject for week number 2. I'm not sure you're asking this because you have seen some lecture videos for maybe for week 2 already. So for the whole for people watching this video, I cannot assume you have watched the video already. So I will simply say for week number 2, it will be very important for you to pay attention to how the post condition is really checked automatically. To really make it work, the pre-state value has to be somehow memorized or cached. And to really see how exactly it works, you have to study the week 2's lecture. And for Jia Hao, if you got a specific question for the lecture, please put it on the Google Doc. And we'll discuss this next Monday or Tuesday. Okay.
Sorry, sir. It's not about the cache value. Actually, it's the violation of the post condition or class invariance. What will happen? How will the compiler react on those two violations?
So you're saying, okay, you're saying when the post condition violation happened, or when the class invariant violation happened, you mean what happened to what? I'm still a bit clear.
Like the post condition will check after the implementation complete, right? So during the implementation, there will be some assignment, right?
Yeah.
So how does the compiler deal with the assigned value?
Oh, you mean how the compiler will deal with the caching process of the values?
No, I mean the post condition check the result is not what we expect it to be. So the new assigned value is not what we want. So how will the compiler, like will they cancel the?
Okay, I see what you mean. Okay, so that will help. When you say cancel, now I can see what you mean. Okay, let's say this. Let's say the following, okay. Let's talk about withdrawal again. Let's say withdraw amount over here, okay. Remember, we have an invariant for the class, which is the balance is strictly larger than 0, okay? And then let's say for the withdrawal, let's say we have a class invariant violation, let's say, just make it simpler, right? When you talk about post condition, it will be a similar idea. So let's say here withdraw, okay? So now, and also do an end, okay? And then let's say you will simply just say balance. Let's say it's a correct implementation. It's assigned to balance minus the amount. Okay, let's say that's what we have. So this is the supplier side that we're going to have. And then we'll look at the client side separately. Okay, so now let's see for the client side. We simply say creates, let's say ACC of type accounts that make, let's say 100. So now the initial balance is 100, right? So now when we say ACC dot withdraw, let's say, let me just make it a little bit smaller. Otherwise, it's a little bit weird to look at. ACC dot withdraw. Let's say 150. Let's say, okay. Let's say there's no precondition. Let's say I just want to make the point. If you got postcondition violation, what's going to happen? If this is really is the case, so that means there's no precondition here, and then we simply execute this implementation here. So gonna be minus 150. So that means balance will be set to minus 50, right? So now, at this point, the balance or the attribute value has been set to minus 50 already. And then, according to the state diagram you saw in week number 1, when you check the 50 against, minus 50 against this invariance, what you will get is you're going to get a class invariant violation, right? Invariance violation. So now at this point, bad thing already occurred to this particular object so that the object of the account becomes invalid because they got minus 50. So you were asking, does the compiler cancel this particular bad effects on the account? The answer is no. So you should, for example, if you take the database course, there might be a way for you to roll back the database for any effects you want to cancel out. But in this case, no, because bad things already happened to the balance. So you will simply already got minus 50. That means that's why you got a counter violation. So to warn whoever is calling this particular feature, right? So the supplier, there should have been a precondition, for example, in here. So does that answer your question?
So the feature call is actually executed, but
it's executed because the reason that the feature is executed is because the precondition is satisfied. It's like a true over here, right?
Yeah.
So if the precondition is satisfied, you will definitely execute the implementation, and you only know about that postcondition or the class invariant is violated after you have done whatever that's here. So it's too late to roll them back. So there's no way to roll them back.
So the object will become invalid, right?
Invalid, correct. That's why you got a class invariant violation. So that means something got to be done around there.
Okay, thank you.
Mm-hmm.
Thanks.
Yes, Ovek, you're right. Does the program crash after counter violation? It does. So that's why in the tutorial video, I kept showing you the stack trace when you run into a counter violation. So that means whenever you see the stack trace for iPhone Studio, pretty much like an Eclipse, right? When things fail, they will show you how the execution lead to that particular failure. So it's a failure, yeah. Okay, so Gleb actually talked about, can you go over deferred versus effective classes? Okay, so guys, according to my clock, we got about 3 minutes. So why don't I answer maybe a few more questions, right, since we're here, okay? The exercises that I gave to you, do try them out, okay? And then we can potentially talk about it at some point, maybe on Monday, okay? But you can feel free to share your answer with me during my office hour. I'll be happy to discuss with you. Okay, so Gleb's question is about, can you go over deferred versus effective classes? Good. Again, so if you feel it might be easier for you just to mention the Java terms, I wouldn't mind, but try to pick it up from now. Okay, so we really, so when you say deferred class versus effective class. Okay, so the Java way to understand this, okay, let's say the Java way, right? They do have a correspondence, okay? You can think about deferred class is really like an abstract class. The reason that they call defer is because they defer the implementation, they delay the implementation for some feature. That's why it's called deferred class, right? So that means it's partially implemented and or equivalently, some implementation is simply deferred. Okay, so there's like an abstract class in Java, right? You have some methods that's implemented. You also got some method that's not implemented. Okay, so what about effective? In Java there, we don't really have the term effective. You can think about in Java term, it's just like a normal class by default. So effective class simply means all routines are implemented. For your lab number 1, you may want to look at the lab number 1. So there's a deferred class over there called the balance BST. So that's the deferred class, which we'll also explain in the comments over there to say there's a deferred class, like an abstract class, where you got some features unimplemented. Okay. How do you come to office hours? You can just go to lectures page, and then you'll see the link over there. Okay, guys, any more questions? All right. Okay, no problem, Gleb. That's no problem. Okay, so guys, I do encourage you to really attend the Q&A session, even though it's optional, but considering you're following such a long lecture video, but if you really got questions, it would be really your benefits to attend the Q&A, so ask me questions. Thank you for coming. So I will be in touch with you later. Okay, so I'll see you next time.